Welcome back to the Deep Dive. Today we are taking a granular look at a piece of equipment that is, well, it's arguably the single most important utility pedal on any serious musician's board, the tuner. But we're not just, talking about tuning in general. We are plunging into the complete, almost geological record of the Bias S TU series.
Yeah.
We're talking the TU2, the TU3, the TU3S, and the Elite TU3W.
Yeah.
We're tracing the evolution of what really became the world standard for pitch detection on stage.
It's so easy to dismiss a tuner, right? It's just a simple necessity. But when you really spend time in the source material, the product engineering notes, the old gear reviews, the accounts from professional touring techs, the Boss S TU series, it reveals itself as this fascinating, 3-decade-long case study in product dominance.
Right.
This isn't just a list of features we're going through. It's a history of technological adaptation, and it's all driven by the brutal, non-negotiable demands of the professional musician.
So our mission today is really to trace this history, model by model.
Exactly. And to understand precisely why this specific line became the universal, unquestioned default for musicians globally.
We have 4 major models spanning from 1998 right up to the present day. So we're charting the course from the original legendary buffered workhorse, the TU2, which really defined the genre, then to the modern, globally recognized benchmark, the TU3. And finally, we get into the specialized variants, the Space Saver TU3S, which is designed for these really sophisticated routing systems.
Yeah, the modern book.
And the ultimate audiophile grade model, the TU3W Wazacraft, which it kind of attempts to resolve the biggest tone debate in pedal history.
Exactly. This deep dive is about more than just accuracy. It's about durability, it's about stage reliability, and the continuous evolution of signal integrity. The TU series literally defined modern pedal board architecture by addressing these critical needs. Not just tuning, but things like power distribution and signal preservation, often in the face of, really long cable runs and difficult stage conditions. We are going to unpack the specific innovations that made each iteration not just good, but necessary for its time.
Okay, let's unpack this and start at the beginning, 1998, with the release of the TU2 Chromatic Tuner. To really grasp its impact, you have to rewind to the era before it existed. What was the tuning situation like for professionals in the, say, mid to late 90s?
Oh, it was. It was a mess. The pre-1998 landscape was just fraught with compromises, especially for any kind of high-profile touring act. The primary challenges the sources consistently point to were threefold: visibility, ruggedness, and integration.
Okay, let's break that down. What do you mean by integration?
Well, if you wanted accurate tuning, you were often stuck with these delicate, expensive rack-mounted units.
All right, the big Korgs and things.
Exactly. Great for the studio, but just terrible on a stage floor. You're not going to put a 1U rack unit at your feet. So then the alternative was you might use these smaller, desktop-style chromatic tuners, which were never, ever designed to withstand being stomped on by a size 12 boot mid-set.
And crucially, visibility was a nightmare. I remember those old tuners.
Yeah.
Under the intense, varied lighting rigs of large venues, and especially outdoors during daylight festivals,
Yeah.
those small LCD screens or weak little LED lights were totally useless.
Completely useless.
You had to practically shade them with your body or your hand just to confirm your pitch. It was unprofessional and it was slow.
And that's where the TU2 just came in and immediately provided the solution. It offered fast, stable chromatic tuning encased in that now iconic signature Bias S metal housing, the one we all know could probably survive a direct hit.
Yeah, the tank.
The tank. But the defining, market-dominating innovation was that emphasis on stage visibility. BSS didn't just add a few lights. They specifically engineered a layout of high-visibility red LEDs designed with the express purpose of cutting through direct stage spotlights and even direct sunlight.
So this wasn't an accident. It was a core design principle.
It was the design principle. This was a critical game changer. It addressed the musician's most fundamental need, knowing definitively if they are in tune instantly under any condition.
That instant confirmation under pressure, I mean, that's what separated the professional gear from the consumer gear, right? The historical impact was, frankly, astonishing. Sources discussing the TU2, they often use phrases like instant market dominance, and they note that it was seen on, this is the quote, virtually every touring rig from the late 90s straight through the 2000s.
Yeah.
This tells us that the TU2 wasn't just another pedal. It solved a persistent, widespread problem, and it established the foundational template for what a professional pedal tuner must be.
It completely normalized the idea that your tuner should live on the floor be stomp-proof, and be usable anywhere. It's no exaggeration to call it one of the most culturally significant Bauhaus pedals ever produced, not for its sound, of course.
No, not at all.
But for its reliability and its sheer utility, it became part of the infrastructure of live music.
So let's talk specifics. The architecture, core features, and, of course, the legendary debate that this pedal introduced to the masses, the bias buffer. What was actually happening under the hood of this thing?
Okay, so at its core, the TU2 utilized a dedicated digital tuning engine, and that was combined with that highly visual LED strength meter. For the time, the functionality was incredibly comprehensive. It had the standard mode button to toggle between general chromatic tuning or optimized modes specifically for guitar or bass.
Which was useful for slightly faster tracking on those instruments, right?
Exactly. It just helped the algorithm lock on a little quicker. And then you had the pitch button, which provided this vital utility for ensemble players, allowing you to adjust the reference frequency. It wasn't just stuck at A equals 440 hertz.
No, you could move it incrementally from 438 to 445 hertz. And that flexibility was crucial for working musicians who, they often had to match a non-standard piano in a club or maybe older orchestral instruments that weren't tuned to concert pitch.
Absolutely. And musically, as genres evolved toward heavier sounds, the flat tuning modes were indispensable. The TU2 was one of the first widely adopted tuners to support full drop tuning scenarios, allowing musicians to transpose their tuning down several steps without losing stability or pitch recognition.
And of course, the silent tuning, the output mute feature, the ability to check your tuning without setting a horrific E-string scrape through the PA system, that was revolutionary for onstage professionalism.
It was. It seems so basic now, but at the time it was a huge leap forward in stage etiquette and efficiency.
Now let's dive into the core of the controversy and really the strength of the pedal, the famous BOSS buffer. The TU2 utilized a buffered bypass. So for listeners who might be unfamiliar with the concept, can you explain why putting a buffer, an active electronic circuit, at the very start of your chain was potentially controversial, but ultimately so beneficial for touring rigs?
Yeah, this is where the real depth of this analysis lies. The controversy, it all stems from the tone purist philosophy, which insists that any active electronics between the guitar and the amplifier will color the tone in some way.
And the preferred alternative for those purists is true bypass, or TBP.
Right. True bypass uses a mechanical switch to completely remove the pedal's circuit from the signal path when it's off. It's like the pedal isn't even there.
But the buffer isn't inherently bad, is it? It serves a critical technical function.
Precisely. It's not bad at all. It's a tool. The BOS buffer is an impedance matching and signal conditioning circuit. So when you run a long cable, say 50 feet from your guitar, through 10 other pedals and then to your amp, that long electrical path introduces something called capacitance.
Okay, and what does capacitance do to your guitar signal?
Capacitance acts like a tiny passive filter that just rolls off your high-frequency content. It makes your guitar tones sound dull, muffled, and lifeless. It's often called tone suck.
So your beautiful, sparkling high-end detail, the chime and the presence, it just bleeds away into the atmosphere because the signal impedance from your pickups is too high for the length of the cable run.
That's exactly right. The TU2's buffered bypass, when you place it optimally right at the front of the pedal board, it essentially converted the delicate high-impedance signal from your guitar pickups into a robust, low-impedance signal.
It strengthens it.
It strengthens it. This strengthened signal could then travel through all those long cables and multiple circuits with minimal high-frequency loss. For a professional player with a large, complex touring rig, that stability and that guaranteed signal integrity were, they were arguably non-negotiable necessities.
Consistency, as you noted earlier, is king. A pro needs to sound the same in a small club as they do in an arena. The buffer provided that essential stability, ensuring the player sounded the same night after night, regardless of venue size or cable length.
Exactly, but the TU2 had another fascinating feature that pushed it beyond a simple utility pedal into a core organizational piece of the pedal board.
And that's the built-in power output.
That's it. The TU2 wasn't just a tuner, it was an integral power distribution hub. It had a dedicated 9V output jack that allowed it to daisy chain power to other pedals on the board.
That is a detail that cannot be overstated for its convenience. For touring professionals relying on massive pedal boards, reducing the number of individual power supplies or wall warts or extra electrical sockets needed on stage, that was a huge logistical win.
A huge win. The TU2 became the electrical foundation stone of the board. It was often positioned first to maximize the benefit of its buffer and to serve as the power input point for the rest of the chain.
So it was the brain and the heart of the board in a way.
The sources really highlight how this multifunctionality solidified its indispensable status. The combination of bomb-proof construction, exceptional stage visibility, buffer-powered signal integrity, and that power pass-through made it the definition of a professional-grade solution.
Looking back, the legacy is just crystal clear. The TU2 shaped modern pedal board culture by establishing the template for stage reliability and all instrument tuning. But every groundbreaking product eventually reveals its limits. What were the specific trade-offs that eventually led BOSS to develop its replacement?
Well, after a decade of dominance, a few things started to show their age. The primary limitation was accuracy. The tuning engine, while very stable, operated at a tolerance of plus or minus 3 cents.
Okay, so plus or minus 3 cents.
While this was perfectly acceptable for standard live performance in 1998, as recording and mixing precision increased over the 2000s, the demand for tighter tolerance grew.
Let's put that into some real-world context for our listeners. Plus or minus 3 cents means a note could be 6 cents wide in its potential range of in tune.
Yeah.
In an orchestral setting, or a very specific studio session, 3 cents of inaccuracy on a single note can absolutely be audible, especially when that note is sustained or layered with other instruments.
Absolutely. For a piano, for example, 3 cents is often the difference between being perfectly in tune and having those subtle, dissonant beats or clashes, particularly in the upper registers. For solo electric guitar, it was fine. But for modern, tighter genres demanding perfect pitch, the tolerance needed to shrink.
And the buffer. We said it was revolutionary for high-end preservation, but the technology of the day meant that the TU2 did have a noticeable noise floor, didn't it?
It did. Compared to later BOSS generations and other premium buffers that came out, the TU2's buffer introduced a slightly taller, audible noise floor. It was particularly noticeable when your gain stages were high or when used with very sensitive, high-fidelity amplifiers.
You'd hear that little bit of hiss in the background.
A little bit of hiss, a little bit of ch. Its display, too, while groundbreaking in 1998, it became visually dated and less efficient as LED technology just rapidly advanced in the 2000s. It was a legend, but the stage was irrevocably set for a successor that could address these modern demands.
So 2009 arrives, and BOSS releases the TU3, which immediately took over the mantle of standard setter. The TU3 didn't just replace the TU2, it perfected the concept, and it remains to this day the most widely used pedal tuner in the world.
The TU3 is a masterpiece of refinement. It really demonstrates that BOSS was listening to a decade of professional feedback. If the TU2 was about setting the bar for rugged visibility, the TU3 was about setting the bar for clinical accuracy and visual intensity.
Let's start with that massive technical leap in accuracy. We moved from plus or minus 3 cents to plus or minus 1 cent. That is a threefold improvement in precision. What does that jump from 3 cents to 1 cent actually mean for the professional musician?
It means the difference between close enough for rock and roll and true studio-grade precision. When you are accurate to plus or minus 1 cent, the note is only 2 cents wide in its potential range, which is, that's virtually imperceptible to the human ear in live conditions.
So it takes any question of pitch out of the equation.
It completely removes it. This level of precision is necessary when multiple instruments are in play-like synths, acoustic instruments, or sampled sounds, all demanding near-perfect synchronization. This made the TU3 not just a great guitar tuner, but a globally useful tool for all musicians requiring critical pitch accuracy.
And the display, the primary visual feature. The TU2's red LEDs were powerful for their time, but the TU3 ushered in a display revolution. It had a significantly brighter, densely packed 21-segment high-brightness LED meter. It just looked and performed like a truly modern piece of technology.
And crucially, it wasn't just brighter, it was smarter. The sources detail the inclusion of intelligent brightness adaptation. This isn't just turning the lights up or down, it's an internal mechanism that actively senses ambient light levels.
Oh, that's clever.
Yeah.
So if you're playing on a massive outdoor stage in direct sunlight, the LEDs automatically hit peak brightness to be visible.
Right.
Then, if the band moves into a dark, moody club or a studio, the LEDs will dim down appropriately so they're not blinding you.
Exactly that. This dynamic adjustment serves a dual purpose. It ensures maximum visibility in varied, difficult lighting, and it reduces eye strain for the user in dark environments. The TU2 was a blinding beacon in a dark room. The TU3 provided calculated optimal illumination. It solved the visibility problem definitively, regardless of the stage environment.
Beyond just visibility and core accuracy, the capacity of the TU3 expanded significantly to reflect shifting musical trends. The 2000s and 2010s saw the explosion of extended-range instruments.
Big time.
7-string and 8-string guitars and 5- and 6-string basses.
That's a key detail that's often overlooked. Tuning a low B string, or even a low A string, is fundamentally difficult for a tuner that was designed primarily for standard guitar frequencies. These low notes, they have really complex overtones, and they often lack the strong fundamental frequency needed for stable detection.
They can make a tuner kind of warble or jump around.
Yes, that hunting behavior. The TU3's enhanced engine was specifically designed to handle these low frequencies robustly and accurately. It officially supports 7-string guitars and 6-string basses, providing stability even at those extreme low-frequency vibrations.
So it wasn't enough to just recognize the notes. It had to lock on them instantly without the glitching or hunting that plagued older tuners when dealing with those low strings.
Right. And it also introduced new display modes that dramatically improved the user experience live. You had the choice between the classic scent display mode, which shows minute pitch variations via a needle,
The one we all
know, or the stream display mode, which provides a scrolling visualization of pitch fluctuation, which is great for identifying drift or seeing if a note is going sharp as you pick it.
But the feature that touring musicians really rave about, the one sources call extremely useful live, is the AccuPitch sign.
Yes. The AccuPitch sign is that unmistakable final confirmation. When the note is perfectly in tune, the display flashes, and it can also provide an audible beep if you want.
Right.
This sensory reinforcement is invaluable. When you are rushing between songs, trying to tune a guitar while the lights are dark and the crowd is cheering, you don't want to stare at a tiny line. You want instant, unequivocal feedback that says, stop, you're good.
The flat tuning modes expanded drastically as well. It now supported up to 6 semitones down.
Yeah, which is catering to the most extreme drop tunings required by contemporary metal and heavy genres. And thankfully, the crucial organizational utility remained. The power out jack for daisy chaining was fully retained.
So it preserved the TU3's role as the power foundation of the pedal board.
Absolutely. It kept all the good stuff and improved everything else.
Now let's revisit the buffer. We established the TU2 had a great buffer for signal preservation, but also a noticeable noise floor. The TU3 features an improved buffer design. What specific improvements did Ballas implement to achieve a lower noise floor while retaining those signal-preserving properties?
It really comes down to a refinement in component selection and circuit design. The TU3 utilizes more modern, low-noise operational amplifiers, or op-amps, and generally tighter filtering within the circuit.
So better parts, basically.
Better parts and a smarter layout. The goal was to maintain that low output impedance and high-frequency content strengthening, but to reduce the inherent hiss or background noise introduced by the active electronics. The sources all describe the TU3's buffer as noticeably cleaner, ensuring better signal clarity and massive pedal boards without contributing that subtle whoosh or hum of the older design.
This is a critical distinction, then. They didn't abandon buffering, they perfected it. They recognized the practical necessity of the buffer for professionals running dozens of feet of cable, but they addressed the primary sonic criticism of the TU2.
Exactly. And this clean, consistent output is why the TU3 cemented its cultural status.
It is the undisputed champion.
Yeah.
I mean, since 2009, it has appeared on nearly every major touring musician's board and is rightly highlighted in our sources as the modern default tuner, likely the most popular tuner pedal of all time.
It's hard to argue with that.
Its reliability is legendary. You can drop it, you can spill beer on it, and it still performs perfectly.
Yet, even the benchmark has its trade-offs in a rapidly changing market. As pedalboard trends shifted toward ultra-compact design, the standard BiSS size, which the TU3 retains, became a consideration. It's significantly larger than the mini pedal format that just exploded in popularity over the last decade.
Yeah, pedalboard real estate became prime real estate.
For sure. And despite the vastly improved low-noise buffer, the TU3 still utilizes a buffered bypass. Even in 2009, and certainly today, there remains a dedicated faction of players, often those using vintage-style low-output pickups or very simple signal chains, who insist on absolute, true bypass purity.
That philosophical divide, buffer versus true bypass, it never went away, did it?
Not at all. even though the TU3 provided the most reliable, accurate, and stable tuning experience the world had ever seen. And that unresolved debate, combined with the rise of complex routing systems, ultimately paved the way for the next stage of the TU lineage specialization.
The pedal board world didn't stand still. As we moved into the 2010s, rigs got tighter and, more importantly, incredibly sophisticated. Programmable loop switchers and MIDI control became commonplace, turning a pedal board from a linear chain of stops into this interconnected, programmable network. This brings us to the adaptation phase of the BiSS tuner lineage, starting with the TU3S.
The TU3S, released in 2016, is a direct response to this architectural shift in pedal boards. If the TU3 was the professional workhorse for everyone, the TU3S is the professional system integrator.
What do you mean by that?
BiSS recognized that for a player using a master switcher like a Boss ES series or a similar competitor, the TU3's heavy-duty foot switch was, well, it was redundant.
Redundant and space-consuming. The modern pedal board philosophy is all about minimalism and efficient use of that real estate we were just talking about. So what was the genius of the TU3S design?
The genius was stripping away the superfluous while retaining the critical technology. The TU3S uses the exact same core components as the gold standard TU3.
So it's the same brain.
It's the same brain, same eyes. The plus or minus 1 cent tuning engine, the intelligent brightness LED display, and the same clean, low-noise buffer. The key difference is the complete removal of the foot switch, which dramatically shrinks the overall footprint, significantly shorter.
And the smaller size allows it to be placed in tight spots, maybe tucked under a top shelf on a tiered board, integrated into a rack drawer, or squeezed into the tight loop of a programmable switcher where every single inch matters.
Its primary use case is always-on operation. When you use a programmable loop switcher, the switcher itself is what controls the mute and bypass function of your signal path.
Right.
The tuner is placed in a dedicated, isolated tuner output or a specific loop. This means the tuner doesn't need its own switch. It simply needs to be visible at all times, awaiting the external command from the switcher to mute the signal path for tuning.
This highlights BiSS adapting to the modern touring methodology. Why stomp on the tuner when your central brain, the switcher, can mute the entire signal path with just one press, allowing you to tune silently while still seeing the display?
Exactly. It's optimization for efficiency. It's perfect for those complex rigs or even for studio musicians who just need a constant visual reference without worrying about accidentally clicking a switch during a take. The tonal profile is identical to the TU3, and it still has the power distribution capability and the same low-noise buffer.
But the trade-off is fundamental, isn't it? The T3S cannot mute the signal by itself.
No.
So if you're a standard 4-stomp box player without any external switching, this unit is essentially useless for silent tuning, as your signal is always passed through, whether you're tuning or not.
It's a very specific tool for a very specific type of professional, the systems engineer disguised as a guitarist. It showcases BiSS moving away from the one-size-fits-all model to providing tailored solutions for the highly demanding touring market.
Speaking of highly demanding, even while addressing space constraints, that tone purist debate never died. In fact, it probably intensified. Players demanded the incredible accuracy of the KEU platform, but wanted flexibility over the signal path. This brings us to the flagship, the technological pinnacle of the series, the TU3W Wazacraft, which was released in 2020.
The Wazacraft designation is huge. In the BiSS universe, Waza means art and technique. It signifies premium refinement, often involving hand-selected components and specialized circuitry designed to elevate a classic circuit into the elite category.
And the fact that BiSS chose their tuner as one of the Wazacraft projects is really telling.
It signaled that they considered this platform worthy of audiophile-grade status. It was about bridging that utility gap with absolute, uncompromising tonal integrity.
This unit exists, really, for one reason: to resolve that decades-long buffer versus true bypass conflict we've been tracing this whole time. The defining feature is the selectable bypass. How did the TU3W finally give players that ultimate choice?
It utilized a high-quality relay system that allows the user to switch between two distinct modes, effectively offering two different tuners in one box.
Okay, so mode 1, the true bypass mode. This is BiSS finally saying, for the purists, we concede. This mode removes all active circuitry when the pedal is off, achieving that absolute signal purity.
That's it. This is for the player using short cables, maybe just a few pedals, and who places that TBP purity above all else.
But the sources make it very clear that the real star here is mode 2, the premium Waza buffer.
Oh, absolutely. Biosys didn't just reuse the excellent TU3 buffer, they engineered a superior version from the ground up. It features enhanced clarity using higher-grade internal components, often metal film resistors and higher-quality op-amps. And the result is greater transparency, superior headroom, and an even lower noise floor than the already clean TU3 buffer.
Can you clarify the concept of headroom in this context for our listeners? What does that mean for a guitar player?
Sure. Headroom is essentially the amount of signal level margin you have before the circuit starts to distort or clip. A superior buffer with high headroom can handle hotter guitar signals, think powerful active pickups or high output humbuckers, without introducing any compression or unpleasant artifacts.
So it won't squash your sound.
It won't squash it at all. The premium Waza buffer is designed to handle virtually any signal thrown at it, reinforcing the signal path over immense cable distances with absolute sonic fidelity.
So if you are that professional running a huge stadium rig with, say, 150 feet of cable between your guitar and the amp, the premium Waza buffer ensures that the highest frequencies, all that sparkle and air, arrive intact and uncolored. It essentially removes the cable from the sonic equation.
It's the ultimate technical argument for buffering. And beyond the bypass choice, the TU3W includes an enhanced tuning engine. While it retains that same plus or minus 1 cent accuracy, the circuitry is tightened up to offer slightly faster detection and improved signal purity within the actual circuit itself. Objectively, it is the best performing, most flexible tuner BISS has ever produced.
The use cases are crystal clear then. It targets high-end professional boards, studio environments where uncompromising accuracy and signal integrity are paramount. And most importantly, players who need the ability to A/B test their signal chain, maybe running true bypass for specific vintage pedals, then switching to the buffer for the rest of the chain. It gives you that flexibility.
The consideration, as always with Wazacraft, is the investment. It is the most expensive tuner in the lineup. And while the internal engineering is miles ahead, the visual experience, the display, and the ergonomics is intentionally maintained to match the TU3. The premium is solely about the audio pathway refinement and the internal performance upgrades.
So the TU3W is BOSS, recognizing the dual reality of the modern guitarist. The technical superiority of a great buffer for complex rigs, and the strong cultural insistence on having the true bypass option.
They provided both in the most pristine package possible.
What an evolution. It's rare to see a piece of utility equipment evolve so methodically, so logically, driven entirely by the increasing demands of the market. We've traced a history that spans from 1998 right up to the modern day, starting with those fundamental stage needs.
It's a perfect product lineage to synthesize it all. The TU2 established the professional template. It focused on stage durability, high visibility, and that essential organizational utility of power distribution, operating at plus or minus 3 cents accuracy via the foundational BSS buffer.
Right, and then that foundation was refined into the TU3 in 2009, which defined the modern standard. It maximized accuracy to plus or minus 1 cent, introduced intelligent lighting, supported extended range instruments, and utilized a significantly improved low-noise buffer, cementing its status as the global default.
Exactly. And finally, we entered the age of specialization. The TU3S in 2016 prioritized compactness and integration for modern switching systems by removing the foot switch, optimizing for space, and always-on use.
And the TU3W Wazacraft in 2020 delivered the ultimate refinement with that selectable bypass, giving players the choice between absolute true bypass or the technically superior premium Waza buffer.
The TU series isn't just a tuner. It's a living document of professional pedalboard evolution. It reflects the shift from needing a reliable, visible workhorse in 1998 to demanding audiophile-grade tone integrity and tight logistical management in the 2020s.
And this continuous evolution, it circles back again and again to the core conflict we've detailed this whole time, the buffer debate.
It does. The sources clearly outline the undeniable, tangible technical benefits of the modern, sophisticated Waza buffer-enhanced clarity, better headroom, complete signal preservation over long distances. I mean, the technical case for the Waza buffer is incredibly strong.
So this raises a critical question for you, the player, to consider as you look at your own signal chain. Given the extreme technical superiority and surgical transparency of modern circuits like the Wazacraft buffer, is the search for pure true bypass in a modern rig still a choice driven by observable tonal integrity? Or is it perhaps a lingering philosophical preference rooted in avoiding the older and noisier buffer technology that plagued the pedal market 25 years ago?
It's a fantastic question. The TU3W offers the answer by giving you the choice. But the real question is, which choice do you truly need for your specific sound? What stands out to you about the necessary trade-offs in this remarkable lineage?
We hope this deep dive has provided the context to answer that question confidently for yourself. Thank you for sharing your sources with us for this exhaustive deep dive into the undisputed champion of pedal tuners. We'll catch you next time for another deep dive.